Welcome back guys. In this video we'll see how to use lambda functions with pandas instead of for loops. Why is it important? Because for loops are extremely slow, and if the interviewer asks you something and you're using for loops and not lambda functions, you are probably getting rejected. So let's get started. In this video we'll see when to use lambda function, when not to, and we'll also benchmark it against the for loops. Okay. So what is the syntax of lambda function? It is just lambda, then we pass arguments, and that's the expression. That is it. I'll give an example. Let's say I am creating a variable square which I'm saying a lambda function which states the argument is x, the value of the x will be squared. When we call this, now the variable is become an argument here. So variable has become a function here because it's a functional. So when we pass 4 in square, it basically squares it. Now if I do the cube of it, okay, I have to connect it out. Let's wait for the connection of it. So if I put the cube of it, I should be getting 64 here and nothing else, because that's how the lambda functions work. Yeah, 64, right? Okay. Now we'll see further how to use it in the data frame. Let's say I have created a data frame naming SKLEKCK, and their scores respectively 45, 85, 62, and I'm printing the values here in of the data frame. This is a good way to print. If you do the markdown method, it shows in a similar tabular format the top 5 rows it shows with the head. Now I am saying that I have to create a new column named grade where the scores are greater than equal to 60 should be marked as pass and the others should be marked as fail. What I can do is either type a for loop, or I can also use a lambda function. How does a lambda function work here? When we type in the data frame, we say that according to this column score column, I have to apply what I am applying a lambda function which states if any value is passed, that value is greater than 6 or equal to 60, mark it as pass, otherwise mark it as fail. And way to save it in a column named grade. You see the column grade is not here. So this method, when we type it here in the data frame, it creates a new column grade and it marks all the values accordingly. Similarly, let's say I'm saying I need to create a new column df test, and I'm saying in according to score column I'm applying the lambda function x such that x by 2 equals to 0. Okay, sorry, I say x is true if x by 2 is 0, else x is x, I say false, right? What does it do? It creates what? Wait, oh, I didn't run it, sorry, my bad. So it creates a new column named test, where it marks if it is divisible by 2, then it will mark as true, else false. So every number is, oh wait, what? Oh, I'm sorry. If it is divisible by 2, it marks as true, else it marks as false. Very simple, right? We could also do this with loops. So we could create a list, then for each and every value in scores, we append the value accordingly, right? If else functions, then we create a new column named grade which loops, and we put on the value of that. Okay. Huh, this is right. Now we see both the values here. If we the grade with lambda and the grade with loop, if we see grade with loop and grade with lambda, both have the similar values, both works accordingly, but lambda is faster. Why is it faster? Because it is in vectorized operations. When it is in vectorized operations, it is faster because pandas works differently over here. Okay, but lambda is not completely vectorized. Vectorized operation, 100% vectorized operations are done using numpy, which is another angle. So, uh, when to use lambda functions? When you need a custom logic involving multiple columns, or you want row level operations or built-in vectorized operations that aren't enough. So, one example I'll show you, like when I apply. So how does this apply lambda works, and how does this df column name lambda works? When I enter a column name, df column name, and then apply lambda where x, so the x passes as a value. For x it will pass as a 45. Let's say for now it is 45. But now if I just directly apply with df and not the column, it applies as a row. So you will have to mention the the complete row and the column. So if I mention row column value, so it says value. So if I say row score, if row is 0, it goes 45. Row score is 45 plus length of row name 2. So it will mark accordingly. 45 plus 2 plus 2 plus 2, because each and every one is 2. Here we'll use lambda functions. Okay. Now, if we have to apply a direct approach, so this is a vectorized operation, internal vectorized operation, which is faster than lambda. Just multiply it with true. We create a double score here. We could also do df double lambda equal to df score dot apply lambda x into 2. That is it. Both operations give us the same results, but this one is faster. We do not have to do the internal vectorization. So the timings is different. The lambdas is faster than loops, but the vectorized operations are way faster than the lambdas. But somewhere vectorized operations cannot be used. That's why we use lambda functions. So that is it for the basic part of the video. Thank you very much. Join in the next thing for other videos.